Hi there, I'm Cody Soska, and this is the Plush Neuron, a teaching tool that models a simple neural network component called a linear threshold unit, or LTU. It's a logical device that computes whether the total input it receives exceeds a threshold. If it does, the neuron fires. Today, I'll walk you through how it works and show how its behavior matches a pure software version called the Neuron Sandbox. Our first example will be the peanut butter and jelly problem, a classic AND function, and we'll compare behavior side by side with the Neuron Sandbox example. For this exercise, we will use the digital and plush neuron to see if we can make a peanut butter and jelly sandwich. Before diving into the actual exercise, let's review the Neuron Sandbox, a software simulation. The inputs are on the left, and each exercise is solve for weights mode. The neuron is in the center, with the net activation and the threshold shown in the circle. To the right are the net activation values, the current outputs, and the desired outputs. These form a visual truth table for the exercise. There are 4 cases to consider, so we have 4 rows. We either have no peanut butter and no jelly, no peanut butter, but we do have jelly. We can have peanut butter but no jelly. And of course, you can have peanut butter and jelly. Our example problem is simple. Can we make a PB&J sandwich? It's a basic AND function. The output is 1, meaning yes, only if we have both peanut butter and jelly. If either is missing, the output is 0, meaning no. Let's see this first in the sandbox and then later with the plush neuron. In both the digital and physical models, we're doing the same thing, multiplying each input by a weight and then summing the results in the net activation. Then we compare this net activation value to a threshold. For this exercise, both weights are 1. And this sum is the neuron's net activation. When we have peanut butter and jelly, we can see the net activation value is 2, which is greater than the threshold of 1.5. So the neuron should fire, meaning it outputs a 1. We can make a PB&J sandwich. As an important note, the rule is strictly greater than, so the neuron won't fire if the sum exactly equals the threshold. It must exceed the threshold. On our plush neuron, we see the light bar on the right is the threshold. The light bar on the left displays the net activation value. Both are 0 at the moment, as shown by a single blue light in the center of each. When we turn the threshold dial counterclockwise, we see red, negative values in the threshold display. When we turn clockwise, we see green, positive values. Note that the values increase in half-step increments for both positive and negative values. A half-bright LED shows this half value. So 1.5 is shown as one fully lit LED and one half-bright LED. Each dendrite has a dial and a light bar to set and display a weight. The bar goes from 4 red LEDs, representing negative values, to a blue 0, to 4 green LEDs representing positive values. For the PB&J problem, we need a threshold value greater than 1, but less than 2, because 2 would be too large, and 0.5 would be too small. We'll use 1.5 instead of 1 to avoid confusion over greater than versus greater than or equal to. A threshold of 1.5 will only be exceeded if the activation is 2. Remember, with the half value increments of the threshold dial, we will see one fully bright LED and one half bright LED. Here is peanut butter. Now if I squeeze the button at the tip of the dendrite, the input is multiplied by a weight of 1, and the product is sent to the neuron body, where it is summed to form the net activation. We see this value displayed as long as we are squeezing this button. If we're not squeezing this button, or if I release it, the net activation is 0, and we go back to a single blue light. Likewise, we can do the same with jelly. Currently, with its weight of 1, when we squeeze the dendrite tip, we get a net activation value of 1, which is below the threshold of 1.5. Having set this up, we now have the correct weights and threshold for the peanut butter and jelly problem. We can see that simply having peanut butter is not enough because the net activation value is 1. Likewise, having jelly but not peanut butter results in the same net activation of 1. Obviously, having neither would not result in the neuron firing, but having both will result in a net activation value of 2, which is greater than a threshold of 1.5. And we will see running white light patterns down the axon, indicating that the neuron fires in this state. Now that we've reviewed how to model sandbox activities using a plush neuron, let's apply all of this to another example from the neuron sandbox. Should I wear boots? This exercise uses a simple OR function to determine if current weather conditions merit wearing boots. All 3 inputs have a weight of 1, and we have 8 cases to consider. In each case, if an input has a value of 1, this means it is present. Like the PB&J exercise, we see the inputs on the left, but we now have 3 inputs instead of 2, one more than the PB&J problem. We do this so that we can use all 3 dendrites on the plush neuron as inputs when we model the same problem. Because we're modeling an OR function, if any single input of rain, snow, or mud is present, the neuron should fire. The net activation value for any input being present will be at least 1. So in order for the neuron to fire, a threshold of 0.5 is appropriate so that a single input will exceed this threshold. As we go down the truth table and map all of the output values, we can see that the neuron fires in all cases except where no inputs are present, because values of 0 in the net activation do not exceed the threshold of 0.5. Like the sandbox example, we will wear boots if any of the following weather conditions are present. Because we're modeling an OR function, if any of these conditions are true, the neuron fires. Therefore, the threshold should be set so that if at least 1 is true, we will expect to see the running white lights on the axon. The neuron should fire. First, let's set an appropriate threshold of 0.5, 1 half-lit green LED. Now, when any condition is present, we will expect the neuron to fire, because even one input with a weight of 1 exceeds a threshold of 0.5. With a little help from a friend, 2 people can squeeze all 3 dendrites simultaneously to show that the neuron indeed fires, because the net activation is 3, greater than the 0.5 threshold. Squeezing all dendrites for a 3-input problem is a great team-building experience. The plush neuron is a fun, physical way to explore how neural networks make decisions. It matches the behavior of the neuron sandbox and helps students see how inputs, weights, and thresholds work together. Whether you're modeling an OR function, or something trickier, it's a great hands-on tool for the classroom. Thank you for watching.